In this lecture, we are going to discuss about one of the important index property of sandy soils. This time, we are trying to speak something in a different way. We are trying to concentrate on how to ensure densification of the granular soils. This is very interesting. In fact, you see, a granular soil means a pure sand and pure gravel, whether they are compacted or not. We want to know the what I say densification of the granular soils. This can be characterized by this index because we are discussing index properties of soils. This time we are discussing one of the important index property of coarse grained soil that I am trying to tell you. The one is particle size, the second one is relative density. Here you see the relative density is old name. Nowadays we people using the word density index. Here you see also called density index. Here I can write now E maximum minus E by E maximum minus E minimum into 100. Someone can ask me what is E? E means wide ratio. What is max? Maximum wide ratio. See, maximum wide ratio could happen in loose state. Minimum wide ratio. So minimum wide ratio could happen in the dense state. That means in compacted state, in a simple language. What is E? Don't worry, E is natural wide ratio. Many times we are finding difficulty in understanding wide ratio because especially determining wide ratio. If you don't have sophisticated equipment to determine wide ratio, we have a simple equation. E is equal to 0 W by rho D minus 1. You can see my previous lecture on these fundamental relationships where you can see E. Sometimes you see you want to write E maximum, E minimum. If you write E maximum, rho D minimum. If you write E minimum, rho D maximum, because specific gravity of solids remains constant, density of water remains constant, minus 1. So that's why you see, by rearranging this equation, 0 W by rho D minimum minus 1 minus 0 W by rho D minus 1, because I'm telling about the E here. E maximum minus E by E maximum minus E minimum. So by rearranging this equation, we will get this rho maximum by rho D into rho D minus rho D minimum by rho D maximum minus rho D minimum. Many times we use it to conduct this experiment in the laboratory about how to determine rho D maximum and rho D minimum. So in the loosest state, we can get rho D minimum. Here you see, where if you take a mold, soil mold, where you maybe poured the sand, where you see we are getting in the loosest state, the mass of the dry soil is less within the same volume of the mold. In the same mold with the known volume, if you compact, in a sense what I am saying, in sandy soils, we use actually vibration in order to compact the granular soils. So where we get rho D minimum. So in fact, you see how to get rho D minimum within the same volume of the mold. Now mass of the dry soil will be reduces because you are now pouring the sand loosely within the same mold, then the mass will be less. If you compact, then it will be more. That's why I'm using these two words, rho D minimum, rho D maximum. So this is the way we use it to determine rho D maximum. And E, as you know how to determine E, natural wide ratio, it can be determined by using this formula, 0 W by rho D minus 1. Very interesting how to determine rho D. We can determine rho D by using core cutter or sand replacement method. But in granular soils, it is obviously we should go for sand replacement method. So how to determine natural wide ratio? This is also a very good discussion. So I am trying to present one question within a short time without taking much time. Here you see we have one question in our end examination. So volume of the mold is given in natural state, in the compacted state, and in loosely pouring state. So one can easily get how to determine relative density, E maximum minus E by E maximum minus E minimum into 100. Now you see here how to determine E maximum, 0 W by rho D minimum, E minimum, 0 W by rho D maximum minus 1 E. So just substitute here. You see mass of the dry soil is constant here, very interesting. So V's are changing. So rho D, capital V. Rho D minimum, V maximum. Rho D maximum, V minimum. Rho D minimum, V maximum. So say goodbye to MD. So I'm getting now a question in terms of volumes. Very interesting. The experimental procedure is changed in the question, but the concept remains same. V maximum minus V by V maximum minus V minimum into V maximum by V. V's are given actually. Maximum volume is given, natural volume is given, and also compacted volume is given. So I'm getting 95.64. It's a very good. I can tell you, it is a dense compacted soil, very dense actually. The degree of densification is good. So thank you all.